Hello everyone, so let's start with today's session. Let me check if I am audible. Okay, so today we are going to revise the complete digital. Okay, I will let you know that first we have completed with the programming subjects, which is Algo, C, data structure. After that we have completed with TOC and CD. Okay, with that we have completed with DBMS, and now today we are going to start with digital. So I want to know you that all the programming subject covers up to 18 to 20 marks in GATE exam. TOC and CD covers up to again 18 to 20 marks in GATE exam. Okay, or let's say till here. DBMS covers 8 marks in GATE exam, and with that if you are good in aptitude, so just take 15 marks. You can sum up them all, and you can see that how much marks you can gain by just preparing this subject. Those who are planning for 50 plus, so they can go with this subject. Okay, but those who are planning for under 100 rank, so for them it is very important to learn CN, COA and OS, because majorly these are the rank deciders. And yes, DMS, discrete mathematics. So these are the rank decider subjects. If you want to be in top 100, okay, or under 100 or under 50, you should have mastered on these subjects. Okay, so solve and practice as much as you can on this subject, because they generally comes for 2 marks. Okay, they generally comes for 2 marks, and these are rank deciders, right? So soon we are going to cover, but my aim was to take those subjects which are very easy to understand. Okay, and with that you can gain more marks, and these are the programming subjects: TOC, CD, DBMS and digital. So these are such subjects which are very easy to prepare, and you can gain more marks in this, and plus aptitude. Okay, so this is what. And engineering mathematics also you can add, because it is all about probability, calculus and algebra. So if you are good with it, then easily you can score the marks. Alright everyone, so I hope that you have watched the past 3 classes, past classes, revision classes, whichever I have taken. That is very useful. They all are of just 1 hour. Okay, only one class is 1 hour 10 minutes, and in 1 hour, okay, we are revising everything. So in some of the subjects, what happened, like TOC was a big subject, so 1 hour class I took for that, and the next class was of TOC plus CD. First I have completed TOC in that, after that I have taken CD. I have continued with CD in it. So it is in a sequence, you can go through it properly, okay, and you can just watch the classes, and they are available in the live section. Okay, they are available in the live section, so you can go and check. And please, that classes are very useful, so please go and watch those classes. These are the last minute revision. Okay, now let's come to our subject. Today it's digital. Let's revise digital very properly. Okay, all the points, let's cover them. Okay, so let's start. Okay, so let's see with gates. Okay, let's revise with gates. So this is not gate. This is AND gate. Third is this is OR gate. Okay, this is A, this is B, this is A, this is B. So this is OR gate. Fourth is this is NAND gate. This is NOR gate. Okay. This is XOR gate. And seventh is this is XNOR gate. So note this, everyone. So today this is a very like easy subject, so we will go little slow because we don't have to cover much in this. Okay, so note this, everyone. Okay, so let's see the next one. Even number of NOT gate. Okay, it is called as buffer. It is called as buffer. It is called as bistable. Okay, it is called as bistable circuit. And odd number of NOT gate This is called as inverter. Okay. So the other names are astable, circuit, square, wave, and clock generator. Alright. And time period is equals to 2n TPD. And frequency is equals to 1 upon 2n TPD. Okay, which is n equals to number of NOT gate in loop. Okay, number of NOT gate in loop. Now let's see all universal gates. Okay, so it is A dot B bar, which is AND, NOR. Okay, this is so these are all universal gates. Multiplexer, so these are all are universal. All are universal. Okay, so note this, everyone. Note this first, and after that I will give you time to note the second one. And till the time, if you have any doubt, you can ask me in the chat box. Okay, so answer this, everyone. So whether you got or not, answer please in the chat box. Any doubts till now? I hope there are no doubts. Let's move ahead. So NAND, NOR are universal logics, okay? And it follows commutative law but not associative law. NAND, NOR follows commutative law but not associative law. But not associative law, okay? And rest except NAND, NOR remaining all follows commutative and associative. Everyone follows associative and commutative law. Now let's see number of NAND gates and NOR gates for other gate. Okay, number of NAND gates, NAND and NOR gate for other gates. Which is NAND, NOR, NOR. So this is not, this is AND, this is OR, this is XOR, XNOR, NAND and NOR. Okay. So how many are they? This is 1, this is 1, this is 2, this is 3, this is 3, this is 2, this is 4, this is 5, this is 5, this is 4, this is 1, this is 4, this is 4, this is 1. So see, this is the chart I have provided, but don't go blindly with this chart. Why? See, because in the exam, one question was there in the previous year where they were saying that all the complements were given. When the complements were given, so this table is not applicable. You have to apply your own mind, okay, to calculate that. So don't go blindly, but just you have to just know that these are the NAND and NOR required to create these gates. Okay. Now number of NAND gates required. So let's see this. Number of NAND gate required. Number of NAND gate required. So case 1. A dot, B dot, C dot, D NAND is equals to 2n minus 2 plus k. Okay. And let's say this k is complement. This k is complement. And this n is variable. And NOR is equals to 3n minus 3 minus k. Okay. Case 2. Case 2 is A plus B C bar plus D NAND equals to 3n minus 3 minus k NOR 2n minus 2 plus k. Okay. So case 3 is equals to, so case 3 is f of equals to AB plus CD, which is 3 gate. Okay. And case 4 is A bar B plus A B bar XOR is equals to 4 gates. So note this cases, very important. Okay. After that we will see the fifth step. Okay, so let's see the case 5. A plus B, C plus D is equals to 3 gates. Okay. Now let's note some properties. A XOR A 0, and this is for even. After that, A XOR A XOR A is equals to A, and this is for odd. A XOR 0 is A XOR 1 is A bar. Okay, so A XOR 0 acts as buffer and A XOR 1 acts as inverter. A XOR A bar is 1. So note these properties, and we will see some properties of XOR and XNOR. So XOR gate output will be high when odd number of gate is connected. Okay, odd number of connected odd number of ones are connected in the input. So it is also called as odd number of ones detector. Okay, so it is also called as odd number of ones detector. Okay, XNOR is also called as even parity detector. Okay, or equivalence logic. Equivalence logic. All right. Now let's talk about standard canonical form, which is each term should contain all the variables. So now let's discuss the functions. Okay, function, so it is SOP, sum of product, POS, product of sum, and it looks like f of AB, which is AB plus A bar B, and this POS looks like f of AB, which is A plus B bar B plus A bar. Okay. After that, you should know some laws such as transpose law. So transpose law is like a plus b, a bar plus c. So this will be like this, ac plus a bar b. So this is transpose law. Transpose theorem, okay, not law. After that, you all are aware of De Morgan's law. So this is De Morgan's law. So it's like break the bar and change the sign, okay? And you all know concise theorem, which is AB plus A bar C plus BC. So how the reduction happens, whenever you see a variable with its complement, so beside whatever is there, if that is the separate term, that you have to cancel, and the reduction will always look like this, AB plus A bar C. But the thing is, we want a variable and its complement, and this one should be at the separate one. So that is when the reduction will happen, okay? So, and one thing I want to tell you that with n variables, so distinct 2 to the power n distinct expression can be formed, where 2 to the power n is min term and 2 to the power n is max term. Alright, now let's see the K-map rule. So in K-map, we have to make a bigger group, okay? That we have to do. So K-map, you should practice it very, very well. K-map practice should be done. After that, you have to know what is implicants, what is prime implicant, what is essential implicant, what is reduced prime implicant, okay? So all of this you should know, because directly question can come out of these topics. So only just writing the definition is not so important, so that is why I'm not writing any definition, okay? But just do okay, note that how to solve this kind of questions. After that, let's see dual, okay? The concept of duality. It converts from positive logic to negative logic and vice versa. Okay? So if 1 is there, then it is 0. If and is there, then it is or. If multiplication is there, then it is plus. And if variable is there, then it is simply variable. So this is dual. And see, in the combinational circuit design, you have to know, find the input and output, that questions. You should know truth table, logic expression, minimal logic expression, and hardware implications, okay? Now let's see n-bit comparator. So 2-bit comparator, 3-bit comparator, and n-bit comparator, you should all know this very well, okay? Now, not, and, or. So here 1, 2:1, mux required, NAND, NOR, XOR, XNOR 2 into 1 mux required. After that, encoder and decoder you should know. So encoder is any circuit used to count any code to binary. Decoder is circuit used to convert binary to any other code. Okay. After that, write BCD. So BCD is nothing but binary coded decimal, which is weight code. Second is not a self complement code. Third is decimal, no decimal number represented by 4 bits. So note this everything for BCD. Done with this, everyone? Any questions on BCD? And yes, so whatever the topic I'm taking, just be prepared with the questions as well. Okay, just see the questions as well of this. So let's see the next, which is access 3 code. So it is not a weighted code, it is self complemented, it is self complemented code. Okay, half subtractor I'm writing. So the difference is A XOR B. Borrow is A bar B. So NAND and NOR how many required? 5 required. Okay. Okay, so now let's see full subtractor. Full subtractor difference is A XOR B XOR C. Borrow is A XOR B C plus A bar B. So which is A bar B, A bar C, B C. NAND NOR required 9 gates. Okay, and one full subtractor is equals to 2 half subtractor plus 1 OR gate. Note this, everyone. Okay, so let's see half adder. So half adder is nothing but 2-bit adder, where sum is equals to A XOR B, carry is equals to AB, and NAND NOR gate required is 5. Now for full adder, it is 3-bit adder. Okay, 3-bit adder where sum is A XOR B XOR C, carry is A XOR B C plus AB, NAND, NOR, GATE required is equals to 9, 1 full adder is equals to 2 half adder plus 1 OR gate, plus 1 OR gate. Okay, so just note this, everyone. Serial adder is t equals to n into t delay number of bits so this is delay of adder. Parallel adder, okay, parallel adder, so this is p is equals to n minus 1 t carry plus more plus max of t sum plus t carry. Okay, look ahead carry adder, look ahead carry adder is equals to ci plus 1 is equals to gi plus pi ci. So this is carry generator term, this is carry propagation term. Okay, now let's see one table, right? So store, retrieve and total, store, retrieve and total, SISO, SIPO, PISO, PIPO, n minus 1, 2n minus 1, n 0, n 1, n minus 1, n 1, 0, 1. So this is the slowest one and this is the fastest one. Okay, now just know about asynchronous and synchronous counter. So asynchronous is slower, synchronous is faster, so have knowledge about that. So know about counter as well. Okay, so max number of state is equals to 2 to the power n, where n is number of flip-flops so modulus of counter, you all know that minus v is up counter and plus v is down counter. Okay, So n bit ring counter is mod n. Alright. N bit Johnson counter is mod 2 to the power n. So it's not power, it's just n, 2n. And unused will be 2 to the power n minus 2n. Okay. So know the table of SR flip flop, JK flip flop, D flip flop, T flip flop. Okay. So have knowledge about that also. See, this is called as positive level trigger. This is called as negative level trigger. This is called as positive edge trigger. This is called as negative edge trigger. Okay. And be good with the conversion, binary to decimal, decimal to octal, octal to hexadecimal, and everything. Any doubts, any question? So see, in digital, just sometimes the questions are asked for 3 to 4 marks. They are not much. Okay. So this much is also, see, be very good with the flip flops and synchronous and asynchronous counter. Okay. Rest the topics are easy, like number system is easy. After that, Boolean algebra is easy. Okay. So have practice about that. Any questions on digital? So now the tough one, but the rank decider subjects are left. CN, OS, COA, maths plus DMS. So this is asked for 20 marks in total. So this is what the rank decider subjects are left, which we are going to cover from tomorrow. So what do you want? Which out of these I should start first? CN I should start, OS I should start, or COA, maths, DMS? Please, in the live chat, please answer, please reply, so that I can take that, okay, in tomorrow's class first. On which subject you want revision? Which is the first I should take? Because these are asked for 2 marks and they are rank deciders. Okay. So let's see the next one. So here flip-flops, it's just the revision and table is there. Be good with the excitation table and everything. Okay. Be good with the conversion. Be good with the latches. Everything you have to see. Expressions also. So SR flip-flop expression is S plus QR bar QN. JK flip-flop, it is Qn plus 1, which is JK Qn bar K bar Qn. After that, be good with level trigger. And JK flip-flop suffers from race condition, race around problem, and to avoid this problem we have different methods, such as the very famous is master slave. So be good with all these topics. After that, decimal number. So base is 10. After that, binary number. Base is 2. Octal number. Base is 8. Hexadecimal numbers. Base is 16. Okay, and one's complement. One's complement ranges from minus 2 to the power n minus 1 minus 1 to 2 to the power n minus 1 minus 1. And 2's complement range is from minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay, everyone. So do you all have any general doubt regarding the subject, regarding the preparation? So whichever the formula I have not covered, so that you have to do. Let's say flip-flops. It is very huge that you have to cover. See, check all of these things. Okay. After that, Boolean algebra. That also you have to cover. Number system representation. That too. Okay. So all these topics you need to cover. So should we take one gate problem in this session? Let's take on number system. So the question is the smallest integer that can be represented by an 8-bit number in 2's complement form is. Can you all tell? In 2's complement form, smallest 8-bit number which can get represented. So yes, this is how the formulas are useful, because directly whatever I have written 2's complement range, on that the question is asked. Okay, so the answer is minus 128. The range is from minus 128 to 127 plus 127. So the smallest is minus 128. After that, the questions on changing the equivalent state is there, like from octal to hexadecimal or decimal. Okay, some number will give you like 1217. This is in the octal form. Converted is into hexadecimal form or decimal form. That you have to do. After that, they can ask you 2's complement range directly. After that, the questions are also very much asked, which is 73x is there, which is x is base number system, which is equivalent to 54y, and y is also base number system. And now we have to calculate the possible values of x and y. So this is also a very nice question, and there is some fixed format to solve such question. This is equal to 54y. So this is 7x plus 3. This is 5y plus 4. So 7x minus 5y, 4 minus 3. So 7x minus 5y, this is 1. And after that, whatever the values are there in option, like 8, 16, 10, 20, 12, 9, 13, 8, 11, just put this, and this is x, y values. Just put this x and y values and calculate which is correct. So for example, if you put this value, 7 8s are 56 and 5 11s are 55. So 56 minus 55, 1. So 1 is equals to 1. So this is the correct answer. So such type of questions are asked, okay, in the exam, and this is the fixed way. And this is the conversion. So this is actually I've converted into decimal form. This is actually I've converted into decimal form. And decimal form, after converting into decimal form, I have just compared it. After that, floating point representation also. Be sure with these type of pattern question. They are also very much famous. Floating point representation. So it is also is in COA and digital. So any doubt, everyone? Because I am ending this session, and from tomorrow I will be taking either CN or COA, okay? Any of the one. So thank you so much everyone for attending today's class. I hope this is beneficial. Thank you so much.